Good morning, everyone. Welcome to my presentation. My name is Koti Kumar Tirumanadham, and here is my title of my presentation: An analysis of diverse computational models for predicting student achievement on e-learning platforms using machine learning. Before we dive into the details, let me give you a brief overview of what we'll be discussing today. The study compares the performance of diverse computational models in predicting the student achievements on e-learning platforms using machine learning. And here is the contents of the study. And first one is an abstract introduction, study objective, literature review, methodology, metrics, resultant analysis, and finally a conclusion. And here is the abstract. The COVID-19 pandemic has accelerated the shift to online learning, making it crucial to develop effective strategies for evaluating student progress. To enhance the prediction of student performance in online courses, three key approaches can be employed. Firstly, selecting the best features is essential to identify the most relevant factors that impact student outcomes, improve the data quality, and reduce dimensionality, the most relevant factors that impact student outcomes. This enhances model accuracy and interpretability. Secondly, balancing unbalanced dataset is critical to prevent biased models and ensure fair and accurate predictions for all students. Effective algorithms can be employed to handle class imbalance and improve predictive performance. Top machine learning models such as random forest, gradient boosting, and AdaBoost can be utilized to leverage this strength and combine them using ensemble learning techniques. This achieves more accurate predictions and improved educational outcomes. Hybrid approaches can also be employed to combination of L2 regularization and recursive feature elimination for optimal feature selection and integrate ensemble learning models for improved predictive performance. By integrating modern machine learning methods, we can maximize the effectiveness of e-learning environments and enhance student performance, ultimately contributing to the development of more accurate and personalized learning systems and improving educational outcomes for students worldwide. And coming to the introduction, the integration of e-learning platforms have a revolutionary education, shifting from traditional classrooms to online environments. E-learning offers flexible and adaptable learning experiences enriched by various instructional media appealing to diverse learners beyond geographical limits. As global education increasingly relies on digital platforms, understanding and enhancing student performance in e-learning is crucial for ensuring online education success. The study examines the complexities of student performance in e-learning, focusing on factors like engagement and academic achievements and satisfaction. The COVID 19 pandemic has accelerated the growth of e learning, with over 2.6 billion users globally, and the industry is projected to reach $375 billion by 2026. The rise of virtual classrooms and technologies like AI and VR continues to transform education, presenting challenges and opportunities for educators, institutions, and policymakers. As e learning continues to evolve, it is essential to develop effective strategies to support student success, ensuring the online education meets its full potential and provides high quality learning experiences for all the students. And here is the study objective of our study. The objective of this study is to explore the transformative impact of e learning platforms on the educational landscape, particularly in the context of shift from traditional classrooms to online environments. The study aims to identify and analyze the key factors influencing student performance in e-learning, including academic achievements and overall satisfaction. Additionally, it seeks to examine the challenges faced by educators and institutions and policymakers in adapting to the rapid growth of e-learning driven by technology advancements and increased reliance of digital platforms following the COVID-19 pandemics. To achieve this study will investigate the key factors that influence student management and achievements and overall satisfaction in e-learning environments. The study will also examine the challenges faced by educators, institutors, and policymakers in adapting And here is the literature review. The literature review on e-learning and its impact on education, particularly in the context of COVID-19 pandemic, has revealed significant insights into student attitudes, satisfaction, and the effectiveness of online learning models. Gullu in 2022 examined the attitudes of health professional students towards e-learning, highlighting the importance of understanding learner perspectives to enhance educational outcomes in digital environment. Gashi in 2022 explored the determinants of student satisfaction with synchronous e-learning during the pandemic, emphasizing the role of interactive and engaging learning experiences in achieving higher level of student satisfaction. Abdullah in 2022 contributed to the discussion by focusing on integration of online and traditional learning, proposing a re-engineered approach by blended learning that aligns with the shifting educational paradigms caused by the pandemic. Ajwalad in 2024 introduced a performance tracking e-learning model demonstrating the importance of monitoring and analyze student performance to ensure the effectiveness of e-learning platforms. Additionally, Thakur in 2023 conducted a comparative investigation between e-learning and traditional learning, providing evidence of the unique advantages and challenges associated with each approach. And coming to the proposed methodology, the proposed methodology for predicting student achievement in e-learning environments is designed to address the complexities of educational data and enhance prediction accuracy. It begins by tackling class imbalance, a common issue in educational datasets which where contain outcomes are underrepresented. To correct this, the synthetic minority oversample techniques mode is applied, which generate the synthetic samples for minority classes, effectively balancing the dataset and improving the model's ability to accurately predict all classes. Next, a hybrid feature selection approach is employed to refine the dataset furtherly. This method combines the L2 regularization and recursive feature elimination. The L2 regularization reduces the coefficients of less importance features to zero, effectively eliminating them, while recursive feature elimination iteratively removes the last significant features. By integrating these two techniques, the methodology generates a optimal subset of features focusing on the most relevant data points that contribute to accurate predictions. Finally, the methodology incorporates an ensemble model consisting of three powerful machine learning algorithms like random forest, gradient boosting, and AdaBoost. Random forest aggregates a multiple decision trees to enhance accuracy and robustness. Gradient boosting corrects errors sequentially, and AdaBoost combines weak classifiers to perform a strong predictive model. This ensemble approach leverages the strength of each algorithm, resulting in more reliable and accurately predictions of student performance in e-learning environments. And here is the schematic diagram of proposed methodology. This diagram illustrates a machine learning workflow of analyzing e-learning data. The process starts with an e-learning dataset that is likely imbalanced, meaning one class might have significantly more data than others. To address this, the dataset undergoes a balancing technique known as SMOT, and next feature selection is performed using hybrid method that combines the L2 regularization and recursive feature elimination. And it's known as R2FE, recursive feature elimination with cross validation. This selection process helps the identify the most relevant features for the model. After the feature selection, the data is fed into the ensemble model, which combines the prediction of multiple individual models. This ensemble model consists of three commonly used algorithms like random forest, gradient boosting, and AdaBoost. These algorithms are chosen for their effectiveness in handling the complex datasets and their tendency to provide robustness predictions. The final step involves comparing the performances of ensemble model with existing models to assess its importance and overall effectiveness in analyzing the e-learning data. And here is the performance metrics. Accuracy assesses the overall correctness of predictions made by the models, and precision evaluates the proportion of correctly predicted positive instances among all predicted positive instances. And specificity measures the ability of models to correctly identify non-recurrence cases. And F1 score harmonic mean of precision and recall, providing a balanced assessment of model performance. And recall measures the ability of the models to correctly identify instance of breast cancer recurrence. And here is the resultant analysis. In our study of predicting academic performance in e-learning environments, we identify the most significant factors using robustness feature selection process. Our datasets, which included demographic data, educational stages, participation records, and academic habits, was analyzed using a hybrid strategy combining L2 regularization and recursive feature elimination. These approaches highlighted 10 key features from 16, including gender, stage ID, grade ID, subject, raised hand, visited resources, and announcements view, and discussion participation, relative activities, and student absence days. These elements provides a comprehensive view of the student's profile and engagement, emphasizing the importance of active participation in e-learning process. When then involved when then employed an ensemble approach integrating random forest, gradient boosting, and ADA boost, combined with the hybrid feature selection strategy, the model demonstrated the exceptional performance with an accuracy of 97% and precision of 96%, the recall of 98%, and the F1 score of 97%. These results indicates that the hybrid R-cube FE feature selection and ensemble learning model effectively capture critical predictors and deliver a strong and consistent predictions of academic performance, significantly enhancing overall predictor accuracy. And here is the conclusion of the study. This investigation into feature selection, handling imbalanced dataset, and protecting student performance in e-learning environments held in several key insights, and which improves the prediction accuracy and model interpretability. The combination of recursive feature selection and L2 regularization has proven effective in identifying the significant features and addressing the classes imbalance, a common challenge in e-learning datasets, is essential to prevent biased models to the favorite of majority classes. Techniques such as smooth and ensemble methods like random forest data boost are crucial for balancing datasets and modeling of robustness. Additionally, machine learning techniques such as SVM and GBM demonstrate strong performance in estimating student outcomes. These advanced methods not only improve model performance but also optimize the instructional and interventions in online learning environments. Future research should aim at scaling these techniques for broader applications in large educational settings and exploring their effectiveness in various contexts of to future and further advance that field. And here is the references which were provided in above literature review, and these are the references which were in our paper. And thank you for the opportunity to present research on diverse computational models for predicting student achievement on e-learning platforms using machine learning. I am grateful for the time and attention on you have given us during this presentation. Thank you very much.